The Young's modulus is the measure of the stiffness of the material. Stiffness is the ability to resist deflection. If the stiffness is more, deflection will be less. So the Young's modulus is commonly used in the selection of materials for different applications. So this Young's modulus is calculated by conducting the deflection test, and this bubble graph shows the Young's modulus of the different materials. The Young's modulus is less, the material is classified as flexible material. If the Young's modulus is more, we can tell the material is stiffer. The unit of Young's modulus is Pascal, Newton per meter square. The Young's modulus can also be found using the tensile test also, using the slope obtained up to the elastic limit. The Young's modulus is calculated by conducting the flexural test on the specimen, and the stress strain graph is recorded, and the slope obtained from the stress strain graph is taken as the value for the Young's modulus. So the value for the Young's modulus for timber is 10 gigapascal, concrete is 21 gigapascal, and the highest value for the Young's modulus is registered for carbon epoxy composite, 220 gigapascal. Suppose you want to select a material for a bicycle frame, it want to carry the load without any deflection or minimum deflection. So if you want to select a material which is having the high Young's modulus, that's why carbon epoxy frames are selected for the sports cycle. Similarly, take the example of the beam. So the plain concrete has 21 gigapascal. Reinforcing the steel with the Young's modulus of 80 to 100 gigapascal makes the concrete slab stiffer, thereby avoiding the deflection or having the minimum deflection. If the Young's modulus is very high, we can tell it is a rigid material. If the Young's modulus is very low, we can tell the material is flexible. Thank you.